Hey guys, this is continuation of Cambridge 2020 past questions, and this is question 6. So the coefficient of 1 over x in the expansion of this is 720. Then find the possible values of the constant a. Okay, so questions like this, you don't need to expand the bracket before you can get the coefficient of 1 over x. All you need to do is to write out the formula for binomial expansion. Okay, so let's consider a binomial expansion of this from p plus q raised to the power of n. So this can be written as summation r equals 0 to n, then n combination r, p raised to the power of n minus r, then q raised to the power of n, q raised to the power of r. Okay, now so this is the formula for binomial expansion. Now let's compare this formula with the given expression, which is 2x plus a over a squared all to the power of 5. So this implies that n here is 5, so you have 5 combination r, p is what, 2x, and this is 5 minus r, and where q is what, a over x squared raised to the power of r. Now remember, we are looking for coefficient of 1 over x. Okay, so for us to get coefficient of 1 over x now, so that means r here must be 2. When r is 2, you have x raised to the power of 4 at denominator, and you have x cubed at numerator. Okay, so when r is 2, so then you now make use of 5 combination 2, then 2x raised to the power of 5 minus 2, okay, then a over x squared raised to the power of 2, and 5 combination 2, that's 10, then you have 2x raised to the power of 3, and this is a squared over x raised to the power of 4. So 2x raised to the power of 3, that's 8x cubed, times 10, that would be 80x cubed. Then a squared over x raised to the power of 4 can be written as x to the power of 3 times x. And of course, this will take this, okay? So you now left with what? 80a squared times 1 over x. So which implies that coefficient of 1 over x, when you expand that binomial expression, that would be 80a squared. All right, so and remember, you've been given the coefficient to be 720, so all you need to do now is to equate what you obtain here to be 720, so meaning that 80a squared equals 720. So you divide both sides by 80, and of course 720 divided by 80, that will give us what? That will give us, I think that would be 9. Okay, then to get a now, so you take square root of both sides, so which implies that a is what? Plus or minus 3. So these are the possible values of constants a, which is plus 3 or minus 3. Okay, so let's move to the b part of the question. Now find the coefficient of 1 over x to the power of 7 in the expansion. So let's go back to the formula we have above here, which is this, where you have 2x plus a over x squared to the power of 5 is equals to what? Summation r equals 0 to 5, then 5 combination r, 2x raised to the power of 5 minus r, then a over x squared raised to the power of r. Now we are looking for coefficient of 1 over x to the power of 7. So what will be the value of r we are going to consider here for us to get 1 over x to the power of 7? Okay, so let's take r to be 4. Okay, when r is 4, you have x to the power of 8 at denominator, and you have x at numerator. Okay, I think that's fine. So when r is 4 now, when r equals 4, so you have 5 combination 4, then 2x raised to the power of what? 5 minus 4, then a over x squared all to the power of 4. Okay, and 5 combination 4, that would definitely give you 5, then 2x to the power of 1, and this is a to the power of 4 over x raised to the power of 8. So, and of course one of this, you take this, so you left with 10a to the power of 4 over what? X to the power of 7, and this can be written as 10a raised to the power of 4 times 1 over x to the power of 7. So which implies that coefficient of 1 over x to the power of 7 is what? Is 10a raised to the power of 4 10 a raised to power 4 is the coefficient. But you cannot leave your answer like this in terms of a. Why? Because you've gotten values for a already. All you need to do is to put those values there to get the actual value for the coefficient. Remember, we've gotten value for a to be plus or minus a 3. So when you substitute that here, that will be 10 minus 3 or plus 3 to the power of 4. That will give us 81. So that will give us 810. So which implies that 810 is equals to what is the coefficient of 1 over x to the power of 7. Okay. Now moving to the next question. The diagram shows the sector AOB, which is part of a circle with center O and radius 6 cm with angle AOB equals 0.8 radians. The point C on B is such that AC is perpendicular to OB. The arc CD is part of the circle with center O, where D lies on line OA. Okay, find the area of the shaded region. So the first thing to do is to analyze the given diagram, the given shapes, before you can write anything out. That should be the first thing. Okay, so looking at the question here, we have a sector, and the sector here is AOB, so which implies that the radii are OA and OB. So, and of course, you've been given OB to be 6 cm, so that implies that OA must also be 6 cm. Okay, now the angle here is 0.8 rad. Okay, and the line AC is perpendicular to OB. Now to get the shaded region, now what do you think we should do here? Okay, now what you have here is a triangle. I mean OAC is a triangle. Okay, then ODC is a sector. Okay, so we can just, for us to get the shaded region there, that will just be shaded region is equals to, now the triangle, now right angle triangle, which is this, okay, minus sector. Okay, so if you remove this sector here from the triangle, you will definitely have the shaded region. Where the triangle you have there, don't forget it is OAC, and the sector is what? ODC. Okay, so now we've seen how we are going to obtain the shaded region now. So what you now need to do now is to find area of triangle and the area of what? Of sector. Okay, so let's start with area of the triangle. Okay, now looking at this, so we have area of shaded region, area of the shaded region was what? Area of triangle what? OAC minus area of sector what? OCD. Okay, now let's start with area of triangle. Okay, for area of triangle, this is what we have for the triangle. Okay, so where we have this point to be O, this is A, this is C, and this is right angle. So we have the angle here already to be 0.8. Yeah, 0.8. And don't forget, you are given what was it called? The radius. Radius is what? So radius is 6 cm, which is OB. So if OB is 6 cm, that means OA is also what? 6 cm. Okay. So now what else do we need to find here now before we can get area of the what? The triangle. Okay. We can make use of area of triangle to be half base times height. Half base times height. So or we make use of, or we can make use of half AB sine theta. Okay, so we can make use of this. So let me use the second one here, half AB sine theta. So let's find OC. So OC here is adjacent to half hypotenuse. So from our SOHCAHTOA, so which one are we going to use here? Which one are we going to use? We need adjacent to half hypotenuse, so we can make use of what? Cos. So cos theta equals what? Adjacent over hypotenuse. Okay, so we have cos 0.8 because adjacent here is OC, then hypotenuse is 6. So by the time you cross multiply here and you press cos 0.8, that will definitely give us 4.18 centimeter. So that will be the value of OC. Now we can now make use of this formula now, which is area is equals to 1 over 2. Our A here is 6, then B is 4.18 with the inclined angle, which is 0.8. So, and when you press this in calculator, this will give us 8.996 centimeters squared. Okay, so that's for the area of triangle. Now we'll find the area of sector now. Okay, so area of a sector, we have that to be half theta arc squared, where r here is what is radius. Now, so from what we have above, this is what we have as a sector. We have something like this as a sector. So where this point, this place is O, if I can remember. So we have DC. Okay, and when you look at this, okay, this place, the length here OB is 6 centimeter. Remember, we've gotten OC to be 4 point something. So let me check here. We obtained that to be 4.18. So that will be the radius we are going to use here. Okay, so that would be 4.18. So this is 4.18. Okay, so this is half. The angle is 0.8. Don't forget that. 0.8 times 4.18 squared. Okay, and this will give us 6.989 centimeters squared. Now area of shaded region now. Area of the shaded region, which is area of triangle minus area of sector. So when you do the calculation, that will give us 2.01 centimeters squared, and that is the result for that one. Okay, so let's move to next question, which is question 8. Now, a woman's basic salary for her first year with a particular company is $30,000, and at the end of the year she also gets a bonus of $600. Okay, for the first year, express the bonus as a percentage of her basic salary. Okay, for something like this, it is, you all need to write out the bonus out. The bonus here is $600, and the salary, we have that to be $30,000. Okay, so to express the bonus in terms of percentage now, that should be bonus, then over salary, then multiplied by 100. Okay, so where bonus is 600 and salary is 30,000, then times 100. So if you do the calculation now, I think this should give us, this take this, this take this, okay, this take this, this take this. So you have 6 over 3, that would be 2. So that's 2%. So that 600 now is 2% of the woman's basic salary. All right, so moving to the next one. At the end of each complete year, the woman's basic salary will increase by 3% and her bonus will increase by 100%. To express the bonus she will be paid at the end of her 24th year as a percentage of the basic salary paid during that year. Okay, so you need to get this right. From the question, the woman's basic salary will increase by 3% and her bonus will increase by 100%. So you now need to express the bonus she will be paid at the end of our 24th year over percent as a percentage of the basic salary paid during that year. What this means is that you will need to find the woman's salary at the end of our 24th year, then you find the woman's bonus at the end of 24th year as well. So just like the case we did for this one, okay, so the same thing applicable to this. The only difference here is that you are not given the woman's salary at the end of 24th, which you are supposed to find, then the bonus at the end of 24th year as well. Okay, so that should be the first thing to do. Okay, so remember the basic salary for the woman starts from, we have 30,000. That's the first salary. Okay, and the salary now from the given parameters here, the salary will increase by 3%. Okay, so which implies that this will be, the next one will be 30,000 times 1.03, then 30,000 times 1.03 squared. So the process continues like that. And when you check this sequence, this is just like geometric sequence. Okay, where the first time here is 30,000 and the ratio here is 0.03, which is 1.03. You know, do you know where we obtain 1.03 from? It's just like 100% plus 3%. You understand? This will give us 103%. Okay, so then when you divide that, that will give us divide 103 by 100, so you have 103%. Okay, so that's the ratio. Now, and we are looking for how many terms are we going to consider here? We are looking for 24 terms. Okay, so because n is 24, end of 24th year, so n is 24. So using the formula for GP, where you have to be AR raised to the power of n minus 1. So U24 now will be, first time here is 30,000 times common ratio is 1.03, then 24 minus 1, that would be 23. Okay, so U24 now, so 1.03 raised to the power of 23 times 30,000, that will give us 59,207.60. So the woman's salary at the end of 24th year will be 59,207 naira. Okay, so that's for the salary. Now let's look for the bonus now. So the same thing for bonus. Don't forget from here we are given that our bonus will increase by what? By 100%. So this one is different from the salary. Salary increases by 3%, while bonus increases by what? By 100%. Okay, and that implies that the first year bonus is 600, so the next one will be that would be, sorry, now the first time here is 600, so this increases by 100%, so we take common difference to be 100. Okay, so we are looking for at the end of 24th term, so we take n to be 24. So here we make use of AP, so where you have Cn to be A plus n minus 1d. Okay, so C24 now, first time is 600 plus 24 minus 1, then times 100. Okay, so this is 600 plus 23 times 100, and this will give us 20,900. Okay, now we've gotten the bonus at the end of 24th year, which is 2,900, and the salary at the end of 24th year, which is 59,207 naira. Okay, so as you all know, to express the bonus in terms of percent, now that will be bonus over salary, so times 100. Okay, so this is 2,900 divided by 59,207.60 times 100. Okay, so from here now you have final answer to be 4.90%. Okay, So that is the bonus of at the end of 24th year. Okay, so now moving on to the next question now. Question 9. Express 2x squared plus 12x plus 11 in the form of a 2x plus a squared plus b. Okay, the given expression is 2x squared plus 12x plus 11. Okay, for something like this, you make use of completing the square method. And one of the steps there is for you to ensure coefficient of x squared is 1. And the coefficient of x squared here is 2. You can't divide both sides by 2 here. I'm sure you know that. So what will you do now? You factorize 2. So when you factorize 2 out, you have x squared plus 6x then plus 11. So I only factorize 2 from the first two terms. Okay, now from here now, consider coefficient of x and divide that by 2. Coefficient of x here is 6. 6 divided by 2, that will give us 3. So this is x plus 3 now, squared, then minus whatever you have here, square of it, then plus 11. So this is 2 x plus 3 squared minus 9, then plus 11. So use these two to expand brackets. You have 2x plus 3 squared minus 10 plus this. So you finally have 2x plus 3 squared. So minus 10 plus 11, that will give us minus 7. Okay, and that is that on that one. So moving to b part. The function f is defined by this: for x less than or equals to minus 4. Find an expression for f inverse and state the domain of f inverse. So if you are to find inverse of quadratic expression or quadratic function, the best way to do it is to use completing the square method. Okay, I mean what we did here, this. So I can just start from here. Since we've gotten the expression already, f of x is 2x squared plus 12x plus 11. And by the time you use completing the square method, you have 2x plus 3 squared minus 7. So you let the whole of this function to be y. So y is 2x plus 3 squared minus 7. So for you to find f inverse now, you just find a way to make x as the subject. So which is y plus 7, then 2x plus 3 all square. Divide both sides by 2, then you have y plus 7 over 2 equals x plus 3 all squared. So what's next here now? We take square root of both sides. So x plus 3 is what? Plus or minus roots y plus 7 over 2. Okay, now this is what we are. Now before you proceed now, let's analyze something here. Remember the domain here is x less than or equals to what? Minus 4. That is the given domain. Now the domain from the given question is x less than or equals to minus 4. Now when you look at this here now, so when you put values less than minus 4 here in x plus 3, the result must be negative at all times. And you compare it to what you have at the right hand side where you have plus or minus. So the only thing that will work for this is for you to consider negative root of this. You cannot consider positive, because from this now it is assumed that x plus 3 must be negative based on the given domain. Okay, so we now neglect the positive, so we consider the negative because of that what's it called, condition. So that is x plus 3 now is minus square root of y plus 7 over 2. That is x plus 3 must be negative at all times. Okay, now so from here now you make x as a subject, so you have minus 3 minus roots y plus 7 then over 2. So which is f inverse of x now is minus 3 then minus roots x plus 7 then over 2. Okay, so that is for the f inverse. Okay, now we have to, this is just like 2-in-1 question. We've gotten the expression for f inverse. Now we need to state domain of f inverse. Okay, let me just manage the space we have here. Let me manage the space. Okay, now f inverse, it is important for you to understand that domain of a function of f is the same as range of inverse of that function. Y range of f is equals to domain of inverse function of the given function. Okay, now since you are looking for the domain of f inverse now, so which is same thing as the range of x, so I think that should be the first thing to do. We look for the range of f, then range of f is same as the domain of f inverse. Okay, now to get range of x, don't forget we have it here that f of x is 2 in bracket of x plus 3 squared minus 7. Okay, and x is less than or equals to minus 4. So in this case now you put minus 4 here. So when x is minus 4, you have minus 4 plus 3 squared minus 7. So this is 2. Minus 4 plus 3, that's minus 1. Minus 1 squared, that's 1. Then minus 7. So this will give us, is that not minus 5? I don't want us to do mistake. Minus 4 plus 3 minus 1. Minus 1 squared, that's 1. So this is minus 5. Okay, so that is the range of f inverse, which is equivalent to the domain of f inverse. So domain of f inverse now is x less than or equals to what? Minus 5. All right, so that is that on that one. Now to the C part of this question. Okay, to the C part, let's look at this in another way first before we move to the C part of this. Okay, from here, okay, I think this should be greater than minus 5. Let me explain this better. Okay, when you look at what you have here, there is no space, but let's just manage. We have f of x. Please, it is important for you to listen to this aspect. It's very important. We have y to be 2x plus 3 squared minus 7. So the turning point here is minus 3 minus 7. And that means when you have the turning point to be minus 3 minus 7, that means the turning point must be at the third quadrant. That's the meaning. Okay, so let's quickly look at that. So we have something like this. So this is the turning point. Okay, now we have this. Sorry, of course, let me just change this back because of the y-intercept. Yes, I think this is better. Okay, so this is the turning point here. And we said the turning point is minus 3 minus 7. So that means x here must be minus 3. Now, remember the domain that we are given is x less than or equals to minus 4. Okay, so if you consider less than or equals to minus 4, now that means we are going to have something like this. So all of this now, we don't need this again because of the given domain. So we only need this curve. Okay, and when x is minus 4, that's when we obtain x to be what? To be minus 5. We obtain the range to be minus 5. Okay, so which implies that the minimum value we can get there for that given domain is minus 5. So that is why we have greater than or equals to minus 5. So I believe that is clear now. Okay, now moving on to the next one, which is for the case the function g is defined by g of x to x minus 3 for x less than or equals to k. Okay, for the case where k is equals to minus 1, solve the equation fg of x equals 198. Okay, so fg of x equals 193. Sorry, where g of x is given to be 2x minus 3 equals 193. And remember, we have f of x. We are using the previous function given for f of x, which is this 2x squared plus 12x plus 11. So that's what we are going to use. So that would be 2x minus 3 squared plus 12 2x minus 3 then plus 11 equals 193. Okay, so when you expand this, you have 4x squared minus 12x plus 9 then plus 24x minus 36 plus 11 equals 193. Expand this one, you have 8x squared minus 24x plus 18 then plus 24x minus 36 then plus 11 equals 193. So minus 24x plus 24x here, so this will take care of this. So which other one again? Okay, So we have 8x squared. So plus 18 plus 11, that's 29. Then 29 minus 36, that will give us minus 7. Then you have 193. So 8x squared equals 193 plus 7, that's 200. So I divide both sides by 8 now. You have x squared to be 200 divided by 8, that will give us 25. And x equals what? Plus or minus 5. Okay. Now, also what happens here? Let's go back to the given questions. So for the case where k is equals to, okay, for the case where k is equals to minus 1, where you have domain to be x less than or equals to k. So the domain here is x less than or equals to minus 1. So now which of these values are we going to consider now? So we consider x equals to minus 5 only, because of the domain that must be less than minus 1, less than or equals to minus 1. So that is that. Now moving on to the next, state the largest state the largest value of k possible. State the largest value of k possible for the composition fg to be defined. Okay, we are looking for the largest value of k for that function fg to be defined. Okay, there is something you need to understand here, is that in fg of x, let me write it out. In fg of x, the range of g of x becomes the domain of f of x. Okay, so why do we have this? Why g of x become, why did the range of g of x becomes the domain of f of x? It's just that since domain of f is x less than or equals to what? Minus 4. So the domain here is less than or equals to minus 4. So the range now, the range g must be g of x less than or equals to minus 4. That's just the meaning. Okay, so since the domain of f is less than minus 4 now, so the range must be what? Must be g of x less than or equals to minus 4. Okay, I'm sure you understand that. Okay, because it is obvious from the here now, fg of x. Okay, we are making substitution for g of x inside f. Okay, and the output of g of x, that's what we are putting in f. So that is why we said the range of g of x becomes the domain of f of x. The output of g of x is what we are putting in f. The case of putting now, that's the input of f, and the input of f is called domain of f of x. Do you get that now? So that is why we have, so for x less than minus 4 now, that means that is the domain. Okay, so the range g must be what? G of x less than or equals to minus 4. So this is what we are going to follow to use it to find, for us to get k. So where g of x, we have that already to be 2x minus 3, then less than or equals to minus 4. So from here you have 2x less than or equals to minus 1, and x less than or equals to minus 1 over 2. So we are looking for the largest. The largest here implies that minus 1 over 2, x is minus 1 over 2, which is k equals minus 1 over 2. So that is the largest value of k we can obtain here. Alright, so let's stop here for today. So if you are just joining us for the first time, don't forget to like, share and subscribe so that you'll be notified. Subscribe so that you'll be notified whenever I release a new video. Thank you.